So I'm going to look at the integral of 1 over x minus 3 quantity squared from 1 to 5. Because it's a definite integral, from here through the rest of the quarter, if you see a definite integral, you first want to check if it's improper. Looking at this, there is a value of x that would make our function undefined. That's if x equals 3, which means this is an improper integral. 3 lies within our bounds. And this time, because 3 isn't at one of the endpoints, we'll actually have to break this up into 2 separate integrals. So I'll be going from 1 to a, just picking a letter there. And we're going to have a limit as a approaches 3. I'll come back and deal with which side it's on in a second. I'm going to go ahead and rewrite this to say x minus 3 to the negative 2, just so that I'm ready to find that antiderivative. Then I'm going to be taking the other piece, instead of from 3 to 5, because 3 makes our function undefined, we're going to pick a letter, and I'm going to let that letter approach 3. So now in our original integral, we were going from 1 to 5, and the problem happens at 3. So for the part of the integral that would be going from 1 to 3 when we broke that apart, all of these numbers are on the left-hand side of 3. So I'd be approaching 3 from the left. This integral that would be from 3 to 5, all of these numbers are on the right-hand side of 3. So this is going to approach 3 from the right. Let's keep going with the integral. Here, if I integrate this, I've got x minus 3 to the negative 2, which means when I integrate that, my new exponent is going to be negative 1, and then I divide by the new exponent. I'm going to go ahead and rewrite that. Instead of x minus 3 to the negative 1, I'll write that as negative 1 over x minus 3 from 1 to a, and I'm taking the limit as a approaches 3 from the left. We're going to plug in our bounds so that we can evaluate the limit. Got negative 1 over a minus 3 minus negative 1 over 1 minus 3. This piece, we can evaluate, it's going to be a number. 1 minus 3, I've got negative 2 on the bottom. So negative 1 over negative 2, it's a positive 1/2. So that's overall minus a 1/2. Now when we take a look at this limit, if I plug in 3 in for a, we get negative 1 over 0. Negative 1 over 0 is undefined. At this point, we already know that the limit diverges. Oops, missing an R. We already know that the limit diverges, but we want to be able to accurately evaluate this limit. Thinking back to 17a, if we get a number divided by 0, that's either headed to positive infinity or negative infinity. And it's generally our job to figure out which one. So if I think about approaching 3 from the left, or I think about some number on that left-hand side of 3, when I plug that in for a, my denominator will be negative because the a value we're plugging in is less than 3. So we would end up with a negative over a negative, which means this limit is going to positive infinity. Again, in terms of deciding whether it converges or diverges, I didn't need to know that. In terms of, okay, if we were in class right now, I'd say, hey, everybody raise your hand. How many people really like to get all of their points on a test? This is one of those subtle things where you'd probably lose a point or two if you didn't get the sign right on whether that was headed to positive infinity or negative infinity. Because once one of our integrals has come out to be infinite or divergent, then I can't somehow make up for that over here. I already have this piece that diverges. Even if this piece happens to converge, the overall integral will still be divergent.